before we get into that other format of doing loops, there's a hazard we've got to be aware of, which I'm just going to do in the script engine, right? So you can do these. So let's see. Let's say we want to start with a counter is equal to 5, while counter is less than 10. Print hello, right? And I just got to make sure I put in my to increment the counter, right? Oh, I forgot to put it in. Oh, what's going on here? Well, notice that it just keeps printing hello, 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 hello. My fans are starting to pick up here because it's just constantly working. I forgot. So remember that was counter. While counter is less than 10, counter started at 5. I never update the value for counter, so it is never stopping being 5. Counter is always 5, so this loop is going to run forever, right? Still printing out here. So now we're stuck here. This is what we call an infinite loop. So first important thing before I go back and review, when you get into an infinite loop, because you will by accident, we all do it, how do I stop it? Let's see. Control D I think works. Nope. Control Z. Oh, nope. Let's see over here. There a options. Oh, wait. It's in a window. Yep, that should work just fine. Okay. What about if I'm inside a shell? Let's do another one. While true. Print still spitting out. Control D, Control Z. So how do we stop this thing? Perhaps our book has some mention of it. Let's see. Ooh. Okay. Trapped in an infinite loop. Control C. There we go. Keyboard interrupt. So that will send a keyboard interrupt to the Python shell. And, all right, so what caused this in this? Well, remember, loops keep running while they're true. So this is while true. Condition is true, so I'm just going to keep printing and keep printing until we send some kind of signal that the program needs to stop. Codition. Well, never claimed I'd be perfect here. So that's kind of important to realize that infinite loops can happen. All right. And a lot of the times they're accidental, right? In fact, most of the time, you'll be doing something similar to what I did, which is you have a counter set up is equal to 5 or equal to 0, counter, or better yet, let's say you have a counter set up and is equal to 10, okay? And instead what we want to do is we want to count down, right? While counter is greater than, so while counter is greater than 0, we want to count this down. Print counter and counter equal to counter plus plus or counter plus 1, right? And this would increment counter, and that's normally what we do, but here I wanted to count down instead, right? So I would want it to have done -1, but a lot of times it's a simple error like this, where I increment where it was supposed to decrement. And watch what will happen, right? It's just going to keep counting up very, very quickly. Look how quickly your computer just goes at this. And it's never going to be less than 0 because I'm counting up away from 0. right? So while counter is greater than 10, so counter is equal to 10, while counter is greater than 0. Let's say print counter minus 1. There we go. 10, 9, 8, 5, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that works just fine. Notice that also the format's a bit different here. Start at 10, while it's greater than 0. It went 10 through 1, but didn't include 0. But it printed out 10 times. Alright, so that's an infinite loop. Another kind of way to break out of an infinite loop is the break statement. So, which we'll learn to be a bit more use a bit more control later. But essentially, while counter is greater than 10. Let's see. Actually, let's go and open up idle for this. Okay, new file. Alright, so what we'll do is that let's search for, let's see. Alright. So while true again. So counter is equal to 10 is equal to 0 while true. If we'll learn about better uses for break, but I just want to but these videos I'm just introducing the concepts for you. If counter is greater than 50,000. Ooh, look at that. You can put blocks of code inside each other. Like, while this is true, if counter is greater than 50,000, break, which will break out of the loop. Print counter. Oh, infinite loop again. Why? Why did I get an infinite loop? That's right, because I never incremented counter. That was unintentional on my part. So now this will run. Notice that it runs a bit quicker in my command line than it does in here. In fact, it's taking a while because it takes a while for it to print out an idle. So let's go ahead and stop and take this print statement and move it over here. So print it out, and it eventually stopped, but it was in a while true loop. Well, once this hit above 50,000, so let's go ahead and put this in print. Right, everything has to be indented properly. It has to be inside the if. It has to be indented inside of the if in order for it to be part of the if. Print. All right. So if the counter is greater than 50,000, print counter. We just reached 50,000. Break. And break broke out of this loop, so we can prove it by showing print done. Let's run it again. Boom, source file. Boom, bam, and we're done. All right. So, with that being said, let's go ahead and instead of going into for loops like I said I was going to do, I'm going to use while loops to write one actual mathematical program, which unfortunately I'll just have to introduce you to some math. Let's see. While primes. Py. All right. So let's go ahead and do something complicated here. So here I want to first off find out if a number is prime. Okay, let's start with that. So how do I know if a number is prime? It's a good question. Well, eventually, so we're going to keep returning to this example because it brings into a lot of aspects of what we've learned. It combines a lot of aspects of what we've learned. Eventually this will get us into nested loops as well as functions and functions with parameters and returning. So this has a whole lot of stuff. I like using prime numbers because even though prime numbers can feel a bit scary, they're not. And they also have a good number of, they are pretty good examples. So let's go ahead and just create a simple prime number tester. Print enter a number. I will tell you if it is prime, right? That's kind of now that we know what the objective of our program is, we can start thinking about it a bit better. Okay, so let's go ahead. Number is equal to input. Right, they're going to input the number. We're going to want to actually turn that into an integer because we're going to be doing some manipulation with it. Okay, so while now how do I know if a number is prime? Let's go ahead and write a comment here. A number is prime if it is divisible only by itself and 1. So in other words, the number is prime if it's, so in other words, let's see. So what are some prime numbers? 5 is prime, 7 is prime, but 6 is not prime. Why is 5 prime? Well, it's only the only numbers that divide it are 1, right? 5 divided by 1 is 5. Cleanly divisible, right? Because you can divide it by 2 and you're going to get 2.5. So cleanly divisible. 3 will not cleanly divide 5. 4 will not cleanly divide 5. 5 cleanly divide 5, right? 5 divided by 5 gets you 1. Right? 5 gives you 1. Right? And then I don't have to check any number beyond that because those numbers are definitely not going to be cleanly divisible because it's going to end up as a fraction. Right? So another thing, we only have to check numbers starting from 2 that are less than the number. So that makes it pretty easy. All right, so that sets up our range. So let's just, before we start checking if a number is prime, let's go ahead and just figure out what numbers are divisible by. So we've got number. So we want to check, so check is equal to 2. We're going to start by checking the number at 2. And while check is, we want check to be all the values from the number up to, but not including the number. So all the numbers less than number. So for instance, if number is 5, we want check to be 2, 3, and 4. But that's fairly simple. Check is equal to check plus 1. Right? So we're just going to run this a couple times and show you. Print number. Oh, not print number, print check. Or printing number would just print out the number you inputted. So let's try 10. It will get, so that's all the numbers that start at 2 but are less than 10. If we put in 100, all the numbers that go up to 100 that are less than 100 but starting at 2. Okay, so now we have to check if any of these are divisible, right? Okay. So let's see. how do I check if something is divisible? Well, that sounds like an if statement. So how can I check if a number is divisible by another number? Well, when I divide a number by another number, I know they're cleanly divisible if the remainder is equal to 0. So if number modded by the check is equal to 0, right? If this number divided by this number has no remainder, then it's cleanly divisible. Print. Well, then we can actually stop checking. Break. Right? So let's move this above. So now if we go up and we print all the numbers up to 100, we stop it. It stops at 2 because it says, oh, 100 divided by 2, that's cleanly divisible. We try, let's see, 25. We'll check divide 2 by 25 by 2, divide by 3, divide by 4, divide by 5. Okay, 25 divided by 5, that's cleanly divisible, so we stop. Alright, but that's not enough to answer our question. So breaking will stop it, but it doesn't, right? We don't have the ability to like say, oh, that's a prime number, right? By breaking out the loop, all we are saying is that we're done with the loop. But if we try this on a number that's prime, right, we'll eventually stop too, just because check is less than number. So what we're going to do is we're going to use a Boolean, is prime. And we're going to assume that the number is prime until we're proven otherwise. So while check is less than number, or and is prime equals true. So here's what we'll do. If we find that it's not the case, if number mod check is equal to 0, we'll do is prime equals false. I suddenly realize this may be a bit harder than I intended it to be, but hey, this is a good example, and it gives me a place to start with when we get to class. Print. So now we can go if is prime. Print. Prime. Else. Print. Not prime. So we put in 100, obviously not a prime number. We put in 17, prime number. So take a look at this program, check it out for yourself. Alright, I think that's it for all the lectures I'm going to have you watch. See you on Tuesday.